Okay, let's go through the quiz real quick, and then we will start today's lesson. So the first one, you're asked to simplify the expression cosecant over all that garbage there. So the key was to recognize that these two things together equal 1. So first step for 1 point is to rewrite this as 1 plus secant theta minus 1. Then you can simplify the bottom. This is point number 2 into just secant theta because the 1 cancels. After that, you go cosecant is 1 over sine, and secant is 1 over cosine. And then if you simplify that by multiplying by the reciprocal, then you end up with cosine over sine, which a shocking number of you identified incorrectly as being tangent. Don't copy off the person sitting next to you. Don't just write down what they write down and assume that it's right. Look at the board. Do your own work. Like that whole back row made all the same mistakes. Okay, so I think I went with 1, or no, is this 5 points? Yeah, so 1 point there, another point there, 3, 4, 5. So 5 points for that. Okay. Good job. All right, number 2, confirm the identity that. So this one is only a 2-stepper. Sine squared plus cosine squared is just 1. And then you can look up there and see that secant squared is equal to 1 plus tangent squared. Some of you made them both into secant squared. It doesn't matter. Either way, you get that they are both the same. Okay? So easy 2 points there. Questions about that? Okay. All right, then the wheels really fell off for some of you when you were asked to solve some of these equations, and I had to give an embarrassing level of assistance for you even to like get on board with this. So we're starting with 2 sine squared x cosine square or cosine x equals cosine x. You're told to solve this by factoring, so that means start by setting it equal to 0. So there's 1 point. Then factor out a cosine from there. So if you did that, there's 2 points. Then you need to set the 2 individual pieces equal to 0 and solve. This one's already solved, so you don't have to do anything with that. This one you have to add 1, divide by 2, and then take the square root. So that gives you sine of x equals 1 over the square root of 2, which you know is the same as root 2 over 2. So there's your third point. And then you look up on your circle chart, where does the x coordinate equal 0? So that is at pi over 2 and 3 pi over 2. And then where does the x coordinate, oh sorry, we take the square root so you get a plus or minus. Where does the y coordinate equal root 2 over 2? That's at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay. Right. Yeah. That cost you about 50 bucks because his numbers were, he had Patriots 3 and Rams 6. What's that? The guy that won all that money, you mean? Yeah. Yeah. I bet he was just like jumping up and down going crazy as soon as he missed that. Yeah. Because anytime you take the square root when you're solving an equation that's plus or minus. Yeah, these should both be plus or minus when you take the square root. Okay. Is that your remediation? You just, okay. Okay. All right, then this one was a little bit more challenging to factor. So a little bit of sympathy if you got this wrong. Although, come on, man. Honors, pre-calculus, top math students in your grade. So I'm going to go 2 sine of x and sine of x in front because those two things will multiply together to give me 2 sine squared. Then I know the only way for me to get a 2 is to multiply a 2 and a 1 together. I'm going to go with a 1 there and a 2 there because if I make this positive and this negative, these two inside terms would multiply together to be negative sine of x. Those two outside terms would multiply together to be 4 sine of x. And if you combine those, you would get 3 sine of x, which is what we want. Okay? So that's how that factors. That's just kind of a guess and check. And I know it was a little bit ugly, but, you know. Okay, so that means that 2 sine x minus 1 could equal 0, or sine of x plus 2 equals 0. In this case, if I add 1 and divide by 2, I get sine of x equals 1/2. In this case, if I subtract 2 from both sides, I get negative 2. So then you look on your circle chart, where does the sine equal 1/2? So that is what, pi over 6? And then there's another one at 5 pi over 6. You can't use the ones on the in the third and fourth quadrants because those are negative 1/2. Then you could look on your circle chart and see where the sine of x equals negative 2 and figure out that there aren't any. Or you could just remember that the sine and cosine graphs go between negative 1 and 1. So that's the largest value that you can have for that. All right? Because if you think about the graph of the sine function, it looks like that. It only goes up to 1, and on the circle chart you would know because there's no y coordinate that equals negative 2. Never shows up. So that means that gives you no solution. Yeah. Indigo, what did you get on your quiz, if you don't mind me asking? Okay, so you're good? Okay, you're making good choices right now? I can please print out a remediation. Which would you rather do? I guess if you just remediate the one you didn't do right, I'd only give you half credit, but if you do a full one, I'll give you full credit. I mean, if you do a full problem, yeah. So if you retake the quiz, then you can get full credit. If you remediate this quiz, I'll give you half credit. So would you rather retake the quiz? Okay. Grace, you too? Yeah. Just that one? You bet. Okay, so short period today, obviously, that's no big deal. We have a short lesson right now. Last week we did the sum and difference identities. Today we're going to do some multiple angle identities. It's pretty much the same thing as what we were doing last week. By the way, trying a new policy for semester number 2, which is that if we have not had a quiz or a test already during the week, we're pretty much going to have one on Friday. Make sure we get one in every week so you guys have more opportunities to demonstrate your knowledge of the things that you've learned, okay? Trying to do that. I tend to forget to give you guys quizzes, which some people probably like and some people don't. Yep, all right, so here's your list of double angle identities. It's a little bit whack. Yeah, weird, huh? 20? All right, so if you are faced with finding sine of 2 times an angle, you can do that by going 2 times the sine of the angle times the cosine of the angle. Cosine of 2u is a little bit more confusing because you have 3 of them to choose from. So just depending on what information you have or what you're trying to find, you're going to have to make good choices that way. Well, these are all u's, so you should be all right. But you can change them all to x's if you want. Anyway, and then tangent of 2u is a little bit tricky as well. Okay? You will see sine of 2u and cosine of 2u maybe 5 times more in your life as a math student. Some of you will see it with me next year in calculus. Others of you will see it in your college calculus class. So, you know, it is what it is. It's worth just half a day to spend on it, Ben. For cosine? Yeah, there's 3 different things that you could do for that one. And all of them will work out, yeah. Correct. Yeah. Holding. I thought about doing it yesterday. All right, so let's go back. I guess I have to make an example for this. Let's say that you wanted to find the sine of, ooh, let's say you wanted to find the sine of, I guess if you double them, then we know them. Well, like if I wanted to find the sine of 120, I wouldn't have to use twice 60 because I just know what the sine of 120 is. And same thing with 45 and yeah, all right, never mind. Okay, good thing it's going to be a short lesson today. How about some half angle identities? You want some of those? Ooh, no, let's not do those. Those look scary. Let's solve. Here we go. Let's use a double angle identity to solve. There we go. I knew there'd be something in here. Huh? Well, that's once around the circle. And I think the reason why they say don't include 2 pi is because if you include 0 and 2 pi, it's kind of redundant. All right, so let's solve algebraically sine of 2x equals cosine of x. And this is probably the way you would see this in a calculus class. So you might go, all right, I could try and get that set equal to 0 and then factor. But there's nothing that I can factor out of sine of 2x and cosine of x. So I'm going to replace the sine of 2x with 2 sine x cosine x. And at the same time, I'm going to subtract cosine from both sides. 2 steps in one. Crazy, I know, but it just might work. Okay. Which one? This one? It's this one subtracted over. Okay, so sine of 2x I turned into this based on the double angle identity that I just gave you. That sine of x equals 2 sine x cosine x. And then this cosine x is right here. Okay? All right, so now we have it set equal to 0. What can I factor out of each term? Cosine of x. Which, yep, this is the exact same as yesterday except, on Friday, but it's not 2 sine squared. It's just 2 sine of x. Which is going to change our answer just a little bit. So I have those two things multiplying together to equal 0. So that means that cosine of x has to equal 0, or sine of x has to equal what? 1/2. So if I go to the circle chart and I try to look for where cosine of x equals 0, you find that at pi over 2 and 3 pi over 2. And then if I try to find where sine of x equals 1/2, so I'm looking for where the y-coordinate is equal to 1/2, that is at, okay. And that's it. Okay. See if there's another one. Hopefully. Nope, don't want to mess with that. All right, good enough for me. Good enough for you guys? Good thing it's a short day. No, I have to make it. Yep. Yeah. What? What's your issue? Did you? Did I add it wrong?